You're listening to Electrician Live with your host, Paul Abernathy. What up, everybody? Welcome to Electrician Live. All kinds of difficulties trying to get live tonight. Again, man, I tell you what, Facebook does not make it easy. It's integrated with the YouTube, and it just seems to drag everything down. Don't know why, but it does. What up, Mohammed? What up, Crud Lot? I guess that's a name. I guess that's the name. Welcome to tonight's little event, a little get-together here, exam prep. Going to look at some things tonight. Try to help you. Been a lot of topics going on the YouTube, Facebook channel today. A lot of controversy. A lot of people talking voltage drop. So I figured we'd do a little voltage drop today. Kind of make sure everybody just gets that. You know you won't get that wrong on an exam. At least we'll do it at the part where you won't get it wrong. So. Other than that, welcome. So, just kind of give it a little bit here, let some people get in here. Hey, Ryan. Don't drop the mic, that's right. Drop the voltage, which is not a good thing for us electrical guys. Whoa, is that thing still zooming in? Wow. I was so lazy tonight, I didn't even mess with the camera. Everybody see my new shirts? Ooh, pretty. Got the logos. Got everything. Got the logo hats. Got all kinds of swag. All right, it's not swag for sale. It's swag for me to wear out at events and things like that. For those that didn't know, I am going to, if you're in Ohio, what's up, Christian? Welcome to the stream. If you're in Ohio next month and in April, it seems like I've got 3 events that I'm teaching in Ohio. I don't know why Ohio, but doing Ohio's continuing education is 8 hours, but I'm doing 4 hours, and I'm doing. And I don't know the dates. That's terrible. I could bring it. I don't know the dates. I think it is March 13th or 14th. I can't remember. 13th, I think. Whatever Thursday is in March, the second week in March. Somebody looked that up. I don't know if it's 13th. I think it's 13th. Anyway, it's a Thursday in March. And then in April 14th, I'm going to be teaching again in Ohio. One of them is for Loeb Electric. So if you happen to be near Cleveland area, Loeb Electric, that's in April. And then the ones I'm doing in, 2 of them I'm doing in March is for Mars Electric. And I'm excited. I think one of my students I had was one of my past students in my Ultimate Guide to the NEC course is actually going to be he's going to be at the training. So that's exciting. So hopefully that'll be awesome. They'll be there for that. So anywho, let's see if I can't. The stream is a little delayed, but hey, it's the best I can do. All right. So as some people kind of come in, I don't necessarily see all of the chats. So let me make an adjustment real quick so I can see as many of the chats as I can possibly can. That way I've got them on the screen to be able to chat back with you. So there we go. I have got them on the screen. Here, bear with me here. There we go. Okay. Looks like it's all good. All right, so sell them. Sell what? What do you want me to sell? Anyway, there's been a lot of things going on. If you haven't noticed, on the over on the Facebook page, a lot of people. What's up, James? Oh, James, I see you. You're on the Facebook stream. Okay, that's why I couldn't see the other night because I wasn't aware you were over on the Facebook stream. Because I can see the comments, but I can't read them. So, what's up, Dennis? Welcome. I see you're over on the stream from the Facebook page. Oh, the hats and shirts. Oh, nobody wants my nice knit shirts. I might look into it if somebody's interested in it, but it's much easier to do the screen print stuff over on Electrician Pride than it is to do this stuff because you have to carry sizes and colors and just a pain. Now, if I do something where people pre-order, then you can wait and then we can get it made and ship it to you. But that type of thing. To be honest with you, it'd probably be cheaper for you to get them. Probably get cheaper for you to get them made yourself, and that type of thing. Anyway, so a lot of stuff going on over on the Facebook page. If you're not a member of our Facebook, man, that sucker has grown, right? That thing went from where I was controlling the number of people as we're waiting for some people to come in for tonight's episode. What happened was, in the Facebook page, there's been a lot of questions on the Facebook, but it went from 900 members, which I tried to keep underneath 1,000, to now it's almost up to 1,800 people in a matter of a month and a half. And I guess because I let most people in now as long as they agree to the rules, and I'll let you in, but you break the rules, I'll kick you out. You stump other people's products other than my own, I'll kick you out. I don't care you talking about it and things like this, but don't come to me if you want to learn the code. And my competitor has a forum, obviously, that teaches code. Go to that forum. Just saying. Daddy's got to eat. I'm just saying. All right. Anyway, let me read some questions real quick before we get started. How you doing? Thanks for information you presented on your podcast. Had a chance to view a few prior to taking my Texas Masters. Awesome. Code portion was a bit challenging. Nevertheless, passed. Hey, as long as you pass. Other people ask me, why do I wear headphones in here and I'm not wearing? I had a question asked me the other day. It's because I have new mics, new systems. I got new lights, but I also have more new lights coming. I actually have a portable system now with all my keyboard. You can't see my console. So that I can start doing some remote location stuff, especially when it gets time. I don't know if you guys knew this. When it gets around time for the code making panel meetings, I'm going to be doing some live shows from there. Y'all will love that. People at the code panel might not love it, but I love it. And since they're open to the public, you get a first-hand seat. So I'm sure that's the first time they're going to hear about this, but I don't care. Unless they kick me off code panel, and that's okay. Whatever they want to do. But I want to bring you into it. So we got so many good things going on. But anyway, that Facebook thing is really growing up. I'll catch these questions here as we get started here in a minute. We got people filing in. So the Facebook's grown, and all of a sudden, today we had some good questions, some good topics in there. I like to chime in too. I don't know it all. I learn stuff new every day. That's the beauty of that forum. If I can help you, I help you. But it's, voltage drop was a question that got brought up today. And again, interesting. I'm going to catch up on these comments. Interesting thing about voltage drop is I see it on so many freaking exams, but it's not even a requirement. Only for, I get it. Only thank you, Klein guy. If it's voltage drop is for fire pumps and things like that, which are never on the exam, ever. I mean, maybe one or two questions, but never anything big. I could teach you everything you need to know about fire pumps on an exam pretty quick. Okay. But the voltage drop thing keeps coming up. So I want to, show you a formulas tonight and just kind of just give you some formulas and things like that. Thanks, Klein guy. I appreciate it. Spread the word. Let other people know. Share it with all your people at your water coolers that we have it on other forums. Let them know. Even if they're haters of mine, it's okay. It's all good. I love haters too. So anyway, we're going to look at that tonight, and we're going to look at some questions in the code again and kind of give you all some experience. I think there's some people on here that might be taking their test as early as tomorrow or even Monday. So we want to cover some of those things. And again, for those reminders, tomorrow night, I am doing my normal 8 p.m. Central Standard Time, and it's going to be on single-family dwelling calculations. But what we'll be doing is breaking up each one of the pieces so that you understand each piece, right? Each piece. Okay, so yes, James, you were on there probably today too. We probably could talk ad nausea, but I'm also going to give you some insight on where the 12.9 or the 21.2 came from on tonight's episode. Okay, you'll never use it, but I'll give it to you anyway. Let's see here. As long as you passed, Klein guy, I'm doing good tonight. Thank you. Had been feeling under the weather for the past week or two and just couldn't beat the bug, but all of a sudden it seemed to be gone and I'm okay. Everybody else getting sick, and then I'm all of a sudden feeling better. So, Dennis, have a hard time passing my exam in Oregon. Any tips and tricks you can share would be helpful. We're going to look over some things tonight. Taking a couple weeks. So the only tip I can give you, Dennis, before we get started into some real, some stuff I've got prepped, is that, obviously, depending on what your score was, if it was really low, then I'd say, really fun. At this point, if it's something where you've studied, and you're down to the last week or two, I tell people it's hard. It's too late now to get in a regimented program. So what you might do is get as many code questions as you can and start looking them up like we do on here. I have about 3 other big videos, 2-hour whatever videos that you can watch, and I encourage you to watch it. And when I put a question up, just pause the screen or pause the video and work the question, and then come back and let it play. That's the way I always recommend any of my videos that are like these live things that are recorded, is watch it, see a question, pause it, and then come. That's kind of what I recommend you do for the most part on that. But other than that, unless we knew kind of where your scores are low, Dennis, then it's going to be hard. I just hit it at it if it's calculations. Also, as you saw me post, y'all probably saw me post on the Facebook page, is I don't think anybody's failing an exam because of one calculation, power factor calculation or some formula or whatever, which I got it in works to do a show that's just going to be dealing with some of those calculations, because I've obviously got one here that I have to work out for a viewer. But I didn't have time today, so I threw something together here real quick. So we're going to go over some questions and stuff like that. But I would think just focus on what you feel your weakness was during the exam. If it's calculations, watch all the calculations we have. If I had to tell somebody how to prepare, just make sure you know how to use the range, 220.55, how doing ranges, 220.54, understand how you do that. A video that talks about when you've got a 3-phase 4-wire system and you're taking a single-phase range that's being connected to a 3-phase 4-wire, and how you do that calculation for those ranges and dryers. Same thing. Let me make sure my stream is okay, guys. I don't want to be talking and you folks don't even hear me. Okay, good. All right. So, all those type of things are what I would make sure that you understand how to use. The basis of single-family dwellings. Make sure you understand standard calculations and all the pieces that are involved in the standard calc. Make sure you understand that. Make sure you understand the basic formulas of optional calculations and all the pieces. Optional being the easiest of all. Okay, general lighting and all the other appliances and everything. You're taking, first 10,000 at 100% and the remainder at 40%. And then, of course, you got your AC and heat, which is totally separate. Okay, so just remember that. What's up, Danny? Welcome to the stream. So kind of those type of things is the best thing I can tell you, Dennis, to prepare for it. But it really would be helpful to know where you found where they gave you a report that says where you might be your weaknesses are at. But get as many exam questions as you can. If you've got 3 or 4 weeks, then I can recommend our exam prep, just the questions only, which is a lot better than what you get online. and there's at least 800 plus on there that you can do online. So we have that program available. But any of them that you can get online at this late stage of the game is going to be beneficial for you. Just remember, as I tell people over and over again, on an effort not to be so redundant, is that it's real important to have a plan. It means that it doesn't matter how long it takes you to look up a question. Now, that's a fallacy people have. And I've taught over 30 years. Look, and I can say that because even back when I was in my training program, I was kind of the teacher's pet, and I was teaching the juniors when I was a senior. So I just like teaching that stuff. So at the end of the day, what I don't teach, honestly, is I left all my engineering stuff back at school. I don't teach far out engineering fundamentals for engineers anymore. I just don't do it. I don't have the capacity to want to do that. All right. And as an electrician, I never use that stuff, most of that stuff. No Ohm's law. Feel comfortable with Ohm's law. Feel comfortable with Watt's law. Really, you might have some series and parallel calcs, very basic on an exam like that. Just make sure you have all the bases, Dennis, all your basic stuff covered. Hi, I am. What is your question here? Listening while driving from Florida to Texas. You're coming back up to Texas. All right, well, drive carefully. I don't want to read about you in the news and somebody says you were listening to me and all of a sudden, don't be a statistic. Hey, Ryan, you passed your journeyman's test after watching my videos and wanted to say thank you. Well, you're very welcome. I'm glad it was beneficial for you, and I'm congratulations on having that license. It means everything. All right, let's see here. We're going to get started in some stuff here. Let me see if I've got anything over on some folks over on. I think James is really the only one over on Facebook. Okay. All right. Okay, so what we're going to do tonight is we're going to look at some voltage drop calculations, kind of let them sear them in your brain. I didn't really have time to put any calculations together for them because I was been busy as crap today at work, and I just didn't have time to work something up. It's getting harder and harder. But I know that I've got to because I got a lot of stuff I got on the plate. Fidel, thank you for following. All right. The Lone Ranger. Yep, it's just you over there. You're the only one on the Facebook stream. It's probably streaming better than the YouTube one does. I know there's a delay tonight anyway. All right, so let's kind of look at it. I'm going to take you over to my present, PowerPoint tonight. So a couple things I've been watching on Facebook, and I see, and I can get involved in it too, and it can get very confusing as well when it comes to different formulas for voltage drop and all this kind of good stuff. So on the screen, you see some basic formulas. Feel free to snapshot the screen if you don't understand them. But basically, the formulas, things that I want to point out is there's a lot of formulas that people will use. They'll actually use the same formula as above, except for they'll substitute, for example, and I'll go over to it so you can see it. Instead of having the values for the K, they'll actually use the resistance in ohms from Chapter 9, Table 8, and they'll use that in place of this as well. In order to come up with these values. That's fine. I've always found it that most exams, most of them, they will either tell you it's copper and use 12.9 or whatever, but I'll show you in a minute how you solve for K, and you basically utilize the values that are in the Chapter 9, Table 8 anyway. Couple things I will mention here is that just remember in the real world, not an exam world, we probably would not use the values that are in Chapter 9, Table 8 when it comes to the ohms per 1,000 feet at 75 degrees C DC. because in the real world, we have reactants and other issues. So typically we would use, depending on what type of raceway you're putting it in, if you're putting it in a raceway, if it's not in a raceway, you just treat it like a non-metallic. But I think the reality is we probably would use Chapter 9, Table 9. But I think you're going to find that the difference is, to be honest with you, it's pretty negligible. It's not going to really change your value that much between whether you use Chapter 9, Table 8 or Chapter 9, Table 9. It's not really going to make that big a hill of beans in the scheme of life. That's why I tell people that it's probably just better to learn the formulas this way: 12.9 for copper, 21.2 for aluminum for K, and just make your life easy. Although there are some people that really will do the values 2 times length times the ohms times the amps and all this stuff, and then they'll take this value and then they'll divide it by 1,000. And there's a way to do it. It's just, this is the easiest way that I explain it in order to pass and to get an exam, right? So let me make sure my stream is still up, guys. Hold on, because I'm having so much trouble tonight. Again, you hear me say this every night. Okay, no, she's okay. All right, so let me go back here real quick so I'm going to get lost. All right, so when you look at this formula here, just kind of remember that single phase is always going to have the 2 involved in it. 3 phase is going to have the 1.732, which is the square root of 3. So 1.732 times L, the length up to the load. Okay, so that's from wherever you're starting out to the actual load. There's your K, which is, again, copper. It's 12.9, aluminum 21.2. And then, of course, I is being your amps. So I always remembered it. This sounds stupid, but I always remember 2, okay, 2L, KI. And when I'm doing it is, no, I'm not even going to say it. It's a little embarrassing. All right, so it's just the way I remembered it back when I was in school. All right, so it doesn't really matter. The other thing to remember here, guys, is on the right in a lot of these formulas, and this is where we saw today, and I was in the middle of meetings when it got posted, and then the individual that I was chiming with, great guy, who was texting me or sending me a notice through the app, and was having a conversation, and I was trying to keep my boss or somebody from seeing me while I still have a VP over me, and he was looking, and and I was trying to answer him, and after it was done, I looked at it and I said, well, that online forum, tests.com, the Ray Holder stuff, I always find quite a few errors in it, and in this case, there was errors again. He got confused, or at least in the answer, got confused with volts versus 3% volts, 3 volts, where he wanted to say 3%. And so it was wrong. It was messed up. So, it wasn't a good reference to use. Hold on for a second. My dogs are in the room. All right. So, sorry about that. I had animals attacking me. So, just remember that when we say in the formula, the first one on the top, when we say the voltage drop, we're actually looking for the volts itself, the actual volts that dropped. We're not looking for a percentage here. You're not looking to put 3% or 5% or whatever it is. You want the actual voltage, okay, the voltage that's dropped, okay? So there's a lot of errors in it. And so I got it on the screen to remember it's the actual voltage drop. So it might say VD, but it's the actual voltage drop. We very rarely ever use the pure 3%. We always want to do a calculation to get our 3%. So whatever it would be, if we're dealing with 240 times 3%, that's going to give you the volts that have been dropped, or the permitted dropped volts that equate to 3% of that value. That's what you're going to use. That's what you're trying to solve for. Right? That's the actual voltages, the volts that dropped. But when you see a formula where it has the VD, then you're looking for the actual voltage, like the second one you see on the screen right here, where it says percentage voltage drop. It's the actual voltage. Okay? All right. Anyway, So these are two formulas that you can utilize. Again, 2 times the length, whatever that may be, times if it's copper, 12.9, times amps, whatever the amps may be. And then it's divided by the circular mils of the conductor that's used. Okay. And that's how you would solve it. Now, if I don't know what conductor I would use, okay, then I drop down to here, and it's still 2 times L times K times I, but then it's over the actual volts, and it'd be 7.2 volts, which is the maximum that stayed within the 3%. This is for 240 volt, by the way. So that's it's going to tell you what the circular mils that I need. Now, it'll give you a value. When you go to Chapter 9, Table 8, obviously it's probably not going to match a value that's in that table, I'm pretty sure. So you just go to the next available one, okay? So, they ask you to go to that, okay? Let's see here. I don't know, Danny, if he's doing the DeWalt or not. I don't think so. He might be. I need that contract. I'll write for them. So these are two good formulas, right? When I need to know the circular mil, then just remember. And so the easiest thing to remember is all you're doing is swapping. Either the circular mils over here, the voltage drops are over here. If you're looking for the circular mils, you put the voltage drop here, and it'll tell you what the minimum circular mils you need. Again, it might not correspond, so you've got to go to the next available size. It's going to give you that minimum. Again, voltage drop is not a requirement in the code. It's an informational note under 210 as well as under 215. It's good design standard. But unless you get unless you get a motor application or something where it can be an issue, then you're thinking about these things. And everybody I talk to, designers, always figure in, voltage drop, even though it's not in the code. So people ask me, why is it not in the code? And we have tried, but it just simply always looks like we as manufacturers are just trying to push bigger wire, or we're just trying to it's what it always it appears to be. But again, it's in the energy code, and you have to follow the energy code. So by proxy, we get it taken care of. So a lot of these have to do with the energy code. It helps push it. And the NEC just makes a note about it. But, I would like to see it actually in, because it does make a difference. If your voltage drop, it's kind of like, I don't want to go this route, but if you're dealing power factors and things like that, you have kVAR, you have kW, you have kWh, which is where the kVAR is the wasted energy. It's still needed in motor applications, induction motors, but again, it's kind of a waste. We're paying for the whole thing, and we only got a part that we work, a part that we waste, and then you pay for the entire thing. And so you learn these different formulas, and they don't serve you. You don't need them that much in real life, but they're right there. But if you do it all wrong, and you do power factor wrong, then you can burn up wires because of power factor, and then the utility adds more, not to mention it charges on more utility cost. So there's problems, but yet we don't even require that too much in the code either. We really don't push that down anybody's throat. So when it comes to voltage drop, it's a real issue if a motor works within a 10% plus or minus of its rating. And all of a sudden now the voltage drop is so low that the motor overheats and burns up. I mean, it could catch on fire. And if it's not working efficiently, then it could end up being pulling more current than necessary. And then the conductors could end up being pulling more current than necessary as it starts to break down. That's a real problem. But it's not in the NEC, okay, requirement. It's an informational note, which is not a requirement. Okay. I'm not sure. Okay, that's a little private between Dennis, and I would think the calculations are probably going to be the same everywhere. Calculation's a calculation for the most part. Okay, so this is your This is some voltage drop formulas. Don't really have any to work, but remember this. If we have any questions tonight, when we're looking at our review questions, and maybe a voltage drop will come up. Who knows? It might. So the next thing to look at is a couple more that I think is interesting to talk about. So here's some more examples of some formulas that you might find pretty handy. So again, you just saw them. 2 times K times I times L, L being length, I being current, amps, K being constant, 12.9 or 21.2 if you're aluminum, and then 2. Remember, single phase, use 2, 3-phase, substitute the 2 for 1.732, which is the square root of 3. Yep. So, and y'all can connect by, if you don't want to share your emails, send me an email. Each one of you send me an email and I'll connect you up. Or you can figure it out however. I'll be your liaison between. All right, so what's up, Derek? Let's see here. Welcome to the stream. So I showed you, some of you might have missed. It might be a little different, but it better not be a different calculation. Oregon can be Oregon, but Oregon ain't that big a deal that it can stop a formula. A formula is a formula. Now, they might ask you something, but I mean, a formula is a formula. They can't change the formula. I don't care who it is. They can't change a formula. It is what it is, right? So, now they might have all kinds of stuff that they have on an exam, but formula is a formula. It's an engineered formula. It is what it is. So here is example, again, for those that saw my... No, you're right. I am. I'm just saying the formula has to be the same because formulas are just formulas. You know what I mean? I mean, there's other methods to do the formulas, but it should be the formula is the formula. But definitely help out, share them. All we want to do is see people pass exams. That's what I want. I want success. That's what I'm shooting for. So definitely share. So you saw those other formulas that I shared on the other page for those that were here. And so here is some more formulas. Again, the same as before, but we have 2 more. And that was if you want to calculate the maximum length and you want to calculate the maximum current. So the maximum length one there is CM, the circular mills, whatever wire you're choosing or whatever wire they give you on an exam, times voltage drop VD. Again, that's the voltage itself. If it's 240 and it's 3%, then it's 7.2. Remember, don't let that throw you on an exam. Make sure that you are using the actual voltages, the volts that are dropped, right? Don't plug 3% right there and get screwed up off the bat. So then it's circular mill times 7.2 if we're dealing with 240 volt, divided by 2 times K, 12.9 if it's copper, times whatever your amps might be, and that's going to equal so the top one divided into the bottom is going to equal your maximum length that you can have with that conductor when it comes to and not exceed your voltage drop. So that's one way to do it for your maximum length. The next one, again, is if you want to find out what the maximum current, then you can do CM times 7.2 if it's 240 volts, divided by 2 times K times L, and that'll give you your maximum current. All right. Let's see here. Whereas the other one is 2 times K times I, this one's 2 times K times L. Okay. See the difference? I is missing from the bottom one and I is in the top one. You get it. You get what I'm saying. Now, people sometimes want to know where the actual, what is 12.9 and 21.2? Where does that really come from? And you see here on the screen how to find K. The first thing we did was go to chapter 9, table 8, and we'll use a 3 conductor, 3 gauge. So 3, I'm looking for the circular mills of a 3. It could be whatever conductor you're dealing with. And for this case, it's 52,620 circular mills. That's what a 3 gauge would be. And then I go to DC resistance. That's chapter 9, table 8, under the 75 degree. That's what the DC resistance is in these examples. And I typically want to use the uncoated. Coated would be tinned. We're just talking uncoated. And I think a problem with Ray's that study material was that he uses coated, like he thinks insulation is a coating. It's not, but it's okay. It's close. It would have been close enough if he hadn't just messed up the percentage thing. Any wrong question, still a good question to learn from, because it creates if something triggers in your head that something's wrong, then that's a good place to start. Definitely learning wise, good place to start. So again, hey, it can't knock the effort of the guy who's authoring, because authoring's hard enough, right? So, I mean, Ray's got some good material out there. That's just some questions sometimes, probably could be proofed and looked at a little bit better. But that's all good. It is what it is. Again, you got to remember, you're just trying to pass an exam and study. So any material that you study with is going to be something worth studying with. Okay. Then if it's wrong, you can learn from it and share it with other people, like we do that's a perfect thing to do on our Facebook page. Share something, right or wrong, just share it, and everybody will chime in. Okay. Let's see. So then we go and find it for the table 8. We go to the column for ohms in feet per thousand, KFT. 1,000 feet, ohms per 1,000 feet. And we look at 3 AWG, and you'll see that it says it's 0.245. Well, in order to convert that so we can do this and find out what the K is, you take the 0.245, you divide it by 1,000, and it's 0.000245. Now, how is the K formulated? You'll see that you take the 0.000245 times the circular mils of the conductor in question, and it equals 12.89 or 12.9. So a lot of people will use the actual value of the ohms, and then they do it by 1,000 at some point in their equation. I just find it so much easier just to learn 2 times K times I times L. I just find it, we know I is amps, we know L is length, we know K is constant. It's easy to remember 12.9 or 21.2. You know what I mean? And 2 being single phase and 1.732 being 3 phase. I just find it easier to remember. But so that's how we find K. So, if you ever wondered, on an exam, don't worry about it. 12.9 or 21.2 for aluminum, and you're good to go. So you've got any of these formulas that can be utilized for doing that. And again, for those that weren't here earlier, that came in late, these are the formulas again. And remember that an exam question has to give you values that you need. Okay, they have to give you what you need to work with. Okay, and so again, making sure that you pick the right formula is real important. Okay, when you're picking your formulas. I can tell you that I don't know very many. Once you get your license, once you get out there, then you'll just be, whipping up these things on your calculator, and you won't be actually doing them on, working them out anymore. And you won't have much need for it unless you're doing post light at the end of a driveway, or you're doing parking lot lighting. Because most people won't even think about it. And residential. How many big homes have you guys wired residential? Have you really stopped? I mean, be honest. How many of you really stopped and calculated out voltage drop for your circuits that are running, 100 feet across the house? I used to do multi-million-dollar homes, and do you think about those now? I will tell you this. I used to think about that when I ran into the hot tub on the other side of a house or something like that. So something I knew that pulled a significant load, then I would think about it. But you don't think about it for the normal circuits, normal branches and things like that. I did think about it on air handling units. I did think about it on air conditioning units. Those are the kind of things that I thought about, but I didn't sit down with a scratch paper to do it like this, even though I know, even though I'm sitting there knowing that it's, 2 times L times K times I, that type of thing. I just, most of the time, I just have the app on my phone. I just pop, 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 pop. Not going to help you in an exam, but it's just good to know. Good to know stuff, right? Okay. All right. So let's go on and go over to what everybody likes, because I don't know how much time I'll have on here tonight, is let's do some exams. Now let's dabble tonight. Let's go into the timed exams. Let's just play around. Let me make sure it's coming up on my screen. Yeah, okay. Okay, hold on for a second, folks. Okay, yep, everything's still on the screen. Okay. Just wanted to check and see where I was at. All right, so we'll start. So if you haven't been in the Fast Tracks program, you know that we got just literally buku of questions. You with me? I mean buku of questions. So this is another example. This is one of the final exams. Now this encompasses everything that you would have learned in the program up to this point. And so we're going to have some questions, and I want y'all to definitely look them up. Hopefully you bought your code books. You look them up. You know the rules. I mean, you can guess if you want. I'm feeling pretty darn lazy tonight. So I've got the code book loaded up. But I do know that sometimes people hate when I go searching back and forth through the electronic NEC, because it's awkward. So in an effort to do it like you folks, because I don't know these answers, I've got my code book, and I will let you know. Look at all them. Look at my stickers on that bad Smamma Jamma. Look at that. Got my master license. Got my code Mafia on my Mafias. I had somebody contact me and say, "How could you call it the Mafia?" You know what my response to them was? Lighten up. Lighten up. God, so tense today. People so freaking crazy. Oh, I should mention that. Let me do that real quick. If you're interested in stickers, I still have some left. I know some of you haven't received some of them yet. It's because I have been, I've been tardy on my efforts. But still have the Code Mafia stickers. Still have the generic electrician sticker. Still have the master electrician sticker. Still have some journeyman electrician stickers. Remember, these until they're gone, and they're gone. I have Code Wizardry, or Electrical Wizardry, I should say. It's one of my favorites. There. And of course, I have got, can't forget, the podcast one. You got to promote our podcast, man. Okay. Anyway, how do you get these? Send me an email. In the subject area, put Paul, I want my stickers, and in the body of it, put your name, your address, and tell me what stickers you want. Whether you want the Code Mafia, the Wizard, Journeyman, Master, Generic Electrician, or whatever. Everybody's going. While I got supplies last, everybody's going to get a podcast one until they're gone. And then I'm not ordering new stickers until these are gone. And I'm going to have, at that point, I'm going to have the stickers that have, the ones that, even though that seems to offend somebody, was the one about God, guns, and family. I'll have that one and a couple other designs, hopefully by then too. But I still got some of these I have to go away. Danny, remind me again, because I went looking and I'm sure I see it somewhere, but I have one of these with your name on it, so make sure you send me your address again. I'm sure I got it, but send it again. That way I know I got it. All right, so, okay. All right, while I'm sitting here telling you about the stickers, Danny was looking it up in the code. He didn't give me the code reference, though. That's because he heard me say I'm going to be lazy tonight. And do y'all mind if my mic is in the view? Most of the time in my videos, it's not in the view, but I don't care. I'm going to put it in the view tonight. I paid good for this professional mic, folks. So, there you go. He didn't look it up. Danny. All right, hold on. I got music for Danny then. I got music for Danny. All right. So let's look at this question because we've been sitting here too long. Okay. For maintenance, the disconnection means for associated swimming pools tells me right there it's in what? 680. You got it. You knew it was. Blank shall be readily accessible and within sight from the equipment to be disconnected. Water pump motors or luminaires. So it's neither one nor two. It's either one only, which is number one, water pump motors only. Both 1 and 2, which is C, as Danny says, both 1 and 2, C. And then it says 2 only. Well, okay. Well, water pump motor, it is a motor. And luminaires, being lighting and things like that. So for maintenance, the disconnection means associated with. So Danny says it's both 1 and 2. Now, if I was looking this up, Danny, let's kind of talk everybody through what I was looking this up. One of the things that I might do, since we're just shooting the breeze, is, if I was looking this up and I knew the code already, I probably would look under. It's something to do with since it says luminaires, as a process of elimination, I'd probably look at luminaires and everything. Let's see here. See what I can see. So Danny says both 1 and 2. Anybody else? Nobody else wants to chime in? Y'all like when I do these code questions. Unless you're wanting me to just show you. Oh, wait a minute. While y'all doing that, while you're doing it, let's look at Mario here. What'd you say, Mario? Hey, welcome to the stream, Mario. Hi, Paul. As it pertains to voltage drop, you don't provide the equipment and the voltage range is plus or minus 10%. Do you believe it's a code violation of 110.3b? What's up, Caleb? Bill? Well, Mario, to be honest with you, what you're really saying is, for those that aren't familiar, what it is saying is that if the manual is provided and the manual says that it has to be plus or minus 10% from the operating value in the manual, and that's what the manufacturer says, then that it has to operate within that range, and you install it, A, B, or C, Danny, A, B, C. And then you install it, and is it a code violation? Well, the voltage drop in the code violation, but it might be not installed in accordance well. So Mario, I can see where some inspectors would do that, probably would do that. But you would have to show me that it says that in the manufacturer's equipment, that it says that and again, for all in fairness, most do. Motors, for example, will give you a range that it operates in, voltage range. And if you're doing something that doesn't operate it, since I'm going to be biased anyway, Mario, on this one, I'm probably going to say I would cite it because, one, I believe voltage drop should be in the code instead of being an informational note. So I would probably, your buddy in Florida might disagree with me, but I would argue that if the instruction manuals say that the voltage is not to drop below 10% or above 10%, and the voltage does, then I would probably argue could be a 110.3b issue. So I don't know if we agree or not. Okay. I got a bunch of answers now. I don't know if that answered it, Mario, for you, my opinion on it. But I'm a believer that all equipment, if it has instructions on how to install it, and we don't install it in accordance with those instructions, then it's a violation of 110.3b, only if it's electrical equipment. And if the electrical equipment you're talking about is electrical equipment, obviously it would be, then it would be a problem. All right, I got a lot of questions. I got a lot of them. So let's follow it up here. Let's see what everybody's got going on here. So Danny says C, which is both 1 and 2. And let's see. Bill says 1, or A, I would assume. Assume that's what you mean, Bill. Derek says A. Derek says A. Then he says B. Come on, Derek. Get off the fence. And Mohammed says 6A.13a. And Christine says 6A.12b, other than luminaires. Okay. And Danny says 6A.12 is his reference. And Derek says B, 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 B. Okay. So everybody, the consensus here is B. I'm gonna reach out, Danny. Consensus says B. So we're gonna test you. See, let's look them up tonight, and we'll look up some of them tonight and help you find the roots. But we're gonna test you guys. You've been coming now for a couple. Let's see if we can test you now. So the majority says B. 680.13 water pump motors only. All right, so one of the tricks that might have been on this one is that you usually don't have for a maintenance disconnect for the luminaires. Although in all fairness, they need to be, the switch would be 5 feet from the edge of the water, from the pool, for example. This one's pretty much talking maintenance, so I was going to let it go out as long as I can, for Danny, but this is a maintenance disconnection requirement. And so if you look at the code for what they say, 680.13, I'll go to the code, so we already know what it is, so I'll go to the code and let you look at it for those that, don't have your code book. Oh, and you know what? We're in 17, in case anybody asks. We're going to use the 17 code tonight. All right, so here's your 680.13, which is a reference it gave. It says, one or more means of simultaneously disconnecting all ungrounded conductors shall be provided for all utilization equipment other than lighting. So there's what's going to get you right there. Okay. So very good. Let's see how we did here. B. A couple of you had A. Let's see. Let me catch up here. We'll do another one. That's pretty good. That was a good start. I think the majority of the people got that one. Let's see here. Mario, I agree. It's a code violation of 123B. Where it's fishy is if plus or minus 10% from equipment voltage or nominal voltage. Well, be honest with you, Mario, I probably would if for me, we're on 2017. And I don't think that changed, Danny. So don't use that one as your excuse. Hold on. I got to do this for Danny again. Danny's going to be tricky tonight. Danny's my trickster in the room. All right. So, yeah, I agree, Mario. What I think that probably, for me, it's the voltage that you would read at the equipment, because that's where it's doing the most potential issue. It's if that motor's got a range, then it's expecting to see it's at its point of connection. It needs to see that. And so when we do voltage drop anyway, when I do the voltage anyway, it's all about the load at the end. That's why it's so important for the load at the end. So I would say that 10 plus or minus 10% from a manufacturer's perspective is what that motor is seeing at the end. So I would say it's to the equipment. Now, other than getting into voltage nominal, I don't know whether or not they mean the nominal like 240 and then the motor's 460 and it's a 480, either or. Good question. I'm always going to use the values that are the same as what I use in the table. So I'm probably going to use those values for the FLC values if I had to be pushed for that. Which means, for me, even though we can use the nominal for the normal system, if the amps that I'm going to get for my FLC are based on this table, and I'm looking at three-phase, and I'm pulling these values, I would probably think the manufacturer wants it to be from the actual value from the table, even though the code tells us in the tables that we can use the nominal or system voltage values. So if it's 480 volts, we know that it's 460 in the table. I would think that the manufacturers would do it from the actual value that we're deriving the actual FLC from. But I don't, I couldn't tell you that. Honestly, I think if you did either one of them and you were consistent with it, I think you'd still probably be all right, because I think 98% of the people out there would know what you're talking about, Mario, anyway, when it comes to voltage drop and whether or not they would cite 110.3b. I don't think they would. I mean, I don't think they would know. Okay. Interesting. Somebody do that, or Mario do one of those based on the 460 versus the 480. Obviously, it's much different. The other thing that I would check is, what is the voltage rating on that motor, Mario? If that motor was listed, even though we use 480, if they list that motor the exact same as what's in this table, which typically is a 460 volt motor, which is being used on a 480, then I would use, if they're saying plus or minus 10% on that motor, then I'd probably use what's on the actual motor itself. The good news is, if you're going to use nominal voltages, then you got a much different window. So be consistent, but I'm probably going to stick, when I'm doing voltage drop, I'm probably going to stick to what's on the motor. Whatever the voltage is, whatever the percentage is, I'm going to stick with that. I don't care what system I'm connecting it to, so that's probably me. You can look at that another way too, because of what we're actually getting the measured voltage. So I could argue it either way. You're going to have to make me think about that, Mario. I never really thought about that. Why you want to bring that in here tonight? Get me all wondering about that now. Shame on you. I got a word. I got something for that one. Hold on. Note to self. Contemplate what Mario said on a deeper level. Okay, I'm going to do it, Mario. I agree that it's a violation of 110.3b, whether you do it from the 480 or the 460. I guess it's, I know I'm spending too much time on this, but I'm thinking the whole issue of the 110.3b is a violation of the motor. So if I'm violating the motor, I would have to use the value that's on the motor, which doesn't make it sound reasonable, since we're probably going to be at 480 volts nominal. But that's what's on the motor, and I'm thinking that's what they tested it at. So it's probably going to be lower than what you really get from 480, so it's probably going to be okay. It's probably not going to hurt the motor. You know what I'm saying? I'm going to have to do something. I'd have to do a calc to see that, because I'm thinking that I would use the rating of whatever the volts is on the motor, and as long as I don't drop below 10% of that motor's voltage rating, then I'm okay. So I'm thinking then electricians are going to use 480, for example, and that value is not going to be lower. So again, you better know which one you're working with. So do you actually calculate that out, Mario? I know you work somewhere down in Florida or somewhere. Do you actually do that on people? Come on, Mario. All right, let's see what's next. Danny, no excuses. Ryan, you like those sounds? Cool. No, it didn't change, Danny. Yeah, the code section changed, but the question didn't change. It has nothing to do with the question. Come on, Danny. Why do you previously exam videos not appear in your library? Some of the ones that are really, really, really long, I don't include all of them, because I can't think that people are going to sit there and watch another 4 hours when I do 4 hours. So some of them in there, but not all of them in there. I choose to put some and I choose to don't. Some of them are just really, really long. A couple of them that were 4 hours long, I didn't put them in there. And then sometimes I had glitches on the recording, and it ticked me off. So I was like, sorry, I never promised I'd give you all of them. That's why you got to come live. You know what I'm saying? Oh, okay, Danny. All right, let's go to another question. All right, so we got that one. There you go. All right, next question. An electrical service grounding electroconductor is to be sized in accordance with the rating of the blank. Okay, so this is a grounding electrode conductor. Okay, grounding electrode conductor. is to be sized in accordance with the rating of the what? What do you think? A, B, C, or D? Should not have to look this one. Oh, wait a minute. Sorry, guys. That's funny. I didn't even have it on the screen. I know Christian said, show the question. I forgot. Come on. Can I make mistakes? Whoop, whoop. Raise the roof. Okay. Actually, I got to go back to Mario. Mario, I'm actually got a guy I'm going to call tomorrow that's is a motor manufacturer. And again, we could do it either way. We know how to do the role. We know how to do it either way. But I'm going to call him tomorrow, Mario. Do me a favor, Mario. Send me an email. And you know my email. I don't care whether it's work. I think you've sent me one before. Send me an email to remind me. And so I can call it. I want to talk to that motor because the motor guys know what their intent is. And I'm going to call the motor guy because I don't care either way. Because if I didn't know, if I was doing it, the funny part about that is if I was doing it on an appliance, and an appliance is probably going to be rated the same rating as whatever the nominal is. So I would do it from the nominal. But I just have a feeling that the manufacturers don't rate it to the nominal. I have a feeling that their plus or minus 10% for them is based on the motor's voltage rating. I just have a feeling. So I wouldn't want inspectors to do something based on the 480 when the manufacturers are doing something based on the 460. Okay? So I wouldn't want to do that. I wouldn't want to cause a problem with them. So, good point. If the utility uses the on the nominal, it's fine. It just seems weird for me. While everybody's looking up this question, should be a no-brainer for everybody. Me and Mario having a little chat here. Then I would think that they would not know, since motors are done, for example, in like it shows in the table. They rate them for a 480 motor. They rate them 4 to 60. If they're going to give you a plus or minus 10%, I would think that they're doing that based off of their rating. So they're building in a cushion because if you use nominal at 480, right, then their value is acceptable even lower. So I think their motor would be fine. So I think that they would love you to do it at 480 rather than do it like at 460. But let me ask I like it at 480. I'd rather do it. Everything else we do at the nominal value. So just motors are weird. And I don't even know if you asked me about motors. I don't know why I went to motors. But I want to call one of my motor guys tomorrow and just kind of chew the fat with them. Because everything else we do based on the nominal. So I'm interested to see what he says. So I'll let you know. All right, I got a lot of D's in here. All right. Y'all didn't even look this up. Oh, I'm sorry, sort of. Yeah, some of them, I guess I get ticked off if I don't think the stream went good or something like that. And just, just gets all funky. Then I end up getting rid of it. You know how many haters I got out there who'd love to just make fun of a bad stream, because people out there got nothing better to do than to hate. Anywho, all right, let's answer this question. Everybody seems to say D, so we'll go with D. Boom, there you go. 250.66, and it talks about it's based on the size of the service conductors. Very good. Y'all are kicking it tonight. All right, next question. Let me make sure I'm even on the screen. I don't want y'all yelling at me again. All right, so here we go. So let's see here. It says, when a one-family dwelling is supplied with a single-phase, 3-wire, 122/40-volt service drop from the local utility company's transformer, the service disconnecting means shall have a rating of at least blank amperes. Hey, so remember we talk about in those exams where you got those questions that you can answer right away, and you're like, yeah, answer that right away, right? And you're like, move on. This should be one that you answer right away, right? Look at the B's coming in. Everybody, boom, boom, boom. B, 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 B. Everybody's a B on there. So somebody tell me what code section that is at. All right, Derek was slow. It must be a delay wherever Derek's at. But that was right, Derek. But it was 250.66, but it wasn't necessarily the table. Okay, it was more or less 250.66, which gives you the language that says that you use the service conductors to size it. Okay, now we will go over to table 250.6, which incidentally is okay for anything other than ground rods, pipe, or plates, and ground rings in a concrete encased electrode, which have other allowances that they can be sized at. Okay, other than that, water pipe ground, in-ground system, anything like that would require you to use the actual table itself. Okay, steel, building steel, in-ground building steel, that'll all require to use the table. But then, of course, you have the allowances in A, B, and C of 250.66 for ground for rod, pipe, or plate, and that's A. And then B, I think, is concrete case electrode, and C is ground ring, or I might have them backwards. Anyway, those are your allowances. Other than that, everything else, underground metal water pipe, got to go to the table. All right. Danny says 230.42. Now he says he's wrong on the reference. All right, Danny, let's go. Let's look. I'm going to look in my code book real quick, guys, before we go looking. Because, again, I told you how I hate to go in that book. The electronic one is just a pain in my buttocks. And I should say I'm looking at the 20. I'm at the 20. You know what? Hold on. That ain't going to be fair. That ain't fair. Had to get out my 2017 with my tabs, which you wanted me to get into a little thing about tabs. You can have too many tabs on a book. I don't care what anybody says. I know there's some people out there that are selling people books that are pre-tabbed, and they literally have so many freaking tabs on it that it literally would, it's just crazy with all the tabs. Tabs everywhere. Tabs, 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 tabs. And what happens is you get analysis paralysis. You get too many tabs. It's kind of the same thing with highlighting, right? You can highlight so much that you literally lose the benefit of why you're doing it in the first place. You with me? So, I mean, sometimes less is best. Or maybe you highlight the stuff that is really important, okay? Maybe you only do one word or two words or something in it. You know what I'm saying? You don't get so to the point where you're just whacking on everything and then all of a sudden, that becomes a problem. And then what happens? You go into an exam. If I open it up and I'm like, it's okay, I'm coming to look at the exam. And then all of a sudden, it all just starts melting together, right? It's not good. To coin a phrase from a friend of mine used to always say, it's not good. It's just not good, Paul. All right? Okay, so in this one here, I'm not getting any other responses unless there's a delay. I will say, Danny, that is incorrect. But the key here is it's a service disconnection means. Okay? And obviously, we're asking about the rating, right? So one of the ways, if you were using the index, Derek, you never have your book with you. We're gonna have to chip in and get you a book. So it is in 230, obviously, services, and so it's for those that are following. If I had to find it in the code book. The easiest way to find it, and I got my code book on the screen. I hate to do that because y'all know how I hate that because it's much easier for me to just open up my code book and look in the back myself. And, tabs can be great, but you can have way too many tabs. And I've seen some people with tabs that are just crazy. I mean, just crazy tabs. Okay. And let's see. Okay. So first thing that I noticed, I'm looking in the back of the book. If you guys that are following, I could look at like we've been doing on the screen, because y'all know that obviously I have, here's the code book. But I'm just going to look in the code book with y'all if y'all are following along. If you look under service equipment, then you'll come down and you'll see that there's disconnection means, and it's looks like it's part 4. Or no, that's part 6. Yeah, that's part 6. Always remember the V and the 1. 6. Okay. Hey, I'm challenged. I'm not nearly as smart as some people. All right, so then you look at it, and you'll go down and you'll see that that's 1. You know, and remember what we said when we're doing exams? We go through and we write down on our scratch paper the things that are critical for us so we don't have to keep coming back in the back of the book. So if I'm underneath, I say book. I am from Texas, but I'm originally from Virginia, so bear with me. Under service equipment, you go down, you'll see disconnection means, which is 230. It's part 6. You're thinking, write that down. Beneficial. All right? And then you keep on going down, and you remember that keyword ratings. We're looking for the rating. So under this one, you happen to get lucky in the index. As you go down, you see rating. It says 230.79. So I'm going to jot that down. And I always tell people, once I know it's in 230, on my scratch paper during an exam, I just write down the section. So I put .79. I put 230 and then .79. And if there's any more in here, then I would put it down as well. Like .80 is there too, so write .80, doesn't matter. So then you go over to 230.79. Or if you wanted, you could have gone to part 6 and you could have looked at the bolds, and you wouldn't have been long before you got to 230.79. It says rating of service disconnection means. And you'll see that one family dwelling, its service disconnection means rating of not less than 100 amps, and it's a 3-wire system. Okay? So kind of how we work that one out. And I would have used the back for that. So it would have been C. So 230.79 C in the 2017 edition. Okay. So there you go, right there. And there it is. Very good. All right. All right, you're in an exam now. Okay. What does Derek say? Hold on, Derek. What do you got? Went to control ed today. Oh, continuing ed today. There you go. Get some classes. You went to get your CEU credits. There you go. All right, so this question says, in general, it's in a general statement now. In general, for sizes 10 AWG copper non-metallic sheath cable NMB, the overcurrent protection shall not exceed 35, 25, 30, or 20. Remember, it said in general. So what do you think? Where do you think the answer is for this one? Now, the mind starts really wondering here because it asks about the overcurrent protection. We got some C's here. And your mind starts to wonder, and you go, oh, I got to go through 334.80. Your mind starts wondering there, and then you're going, is that good? I know that it tells me that 60 degree. And we're not even asking you about ampacity that much right now. You know what I mean? I mean, we're just saying in general. So on an exam, this would be in general. All right? So one thing to remember is if we width that angle, the values in 310.15b16 as far as ampacities really don't mean squat except for the double asterisk, which is going to send us to 240.4, right? And when you get there, you're going to see small conductor rules and things like that, protecting small conductor rules. So this is an example on an exam. You just bought yourself some time. If you try to remember that you're not trying to find an ampacity value, you're trying to find an overcurrent protective device value, and just remember small conductor rules. So in this case, if I was looking at this, if I just didn't know, I'm not going to go in the back looking for NMB, in 334. I'm not. So I'm in the index. If I was using the index, again, there's going to be a lot of these questions you don't need the index. But if you were using the index and I was trying to find something, then I might go back and look at overcurrent protective device. Maybe. For me, I wouldn't have to. You probably wouldn't have to either because y'all got this question, I believe, and you would have moved right on, or maybe nobody's answered it yet. But I will do the back of the book. I'm gonna look in here without doing it online again. Y'all know how painful it is for me to look online, because hopefully, I just realized when I do it online, it encourages you guys not to bring your code book, Derek. So, you know what? I'm gonna stop teasing Derek, because he's gonna stop coming to my stuff. Don't do that, Derek. I enjoy you here, so it's okay. I've got the code book. I'll look it up. Okay, so overcurrent protection. I can see that there, and if I were to look down it, just peruse down it and think of what I'm in my mind, what I'm looking for, just to see if there's anything here that might help you. There's conductors. And it says go see conductors, so I keep that in the back of my mind if I don't find anything. And I'm just looking down to see real quickly. I'm glancing it down. Again, as we talked many times before, the index is not the Holy Grail. Okay, it's not the Holy Grail, but sometimes it can be helpful. So I'm just going to look down, see if there's anything in here. No, I don't see anything in it that really floats my boat when it comes to anything like that. Now, I could go over and look at conductors if I wanted to, and I do. Why not? I'll go look at conductors and see what it says. Again, I'm on an exam. I mean, I ain't got a whole lot of time, but when we're doing this, we can. So I'm just looking and seeing what I might see. And you should be doing it too. If you find an example, Jeff has come onto the scene. Jeff's already looked it up. He's the only one that's provided me with a code reference. So let's see. Okay, so I'm looking right now. What I'm doing, I'm just looking to see if there's anything that would give me any guidance at the back of the book. I do this enough with students a lot, and what it does is it helps you learn the index a little better for what might be and what might not be it. Okay. So you kind of just go through and look and see what you've got. I think Danny said it's under overcurrent protection, then small conductors. Okay. Let's see here. Just looking to see what I might see. If you found it already, post your answer there. Okay. All right. So what did we say? Was that overcurrent protection? Danny, I didn't see that. And I probably wouldn't have even been back there in the beginning, because I knew the answer to this, and most people should know the answer to this one. But if you don't, let's see here. Under overcurrent protection, you said look under overcurrent protection, then small conductors. Okay, I'm over here. Overcurrent protection, and I'm looking for the reference to small conductors because Danny says it's there. So I'm gonna look. All right, Danny, I must be missing it because I'm not seeing the reference to small conductors anywhere. I probably am missing it. As I get older, my eyesight just gets worse, but I don't see any reference to small conductors. So anyway, 240, over at 240.4, we know that there's a small conductor rule. So if we're studying for an exam, that's kind of those things. So just remember, overcurrents 240, small conductor rules. Interesting thing about small conductor rules, while I got you here, might as well talk about it. Okay, we're going to talk about it. You ready? I forgot what I was going to talk about. Hold on, let me do it again. I had an epiphany. So what we're talking about is motors and HVAC and all that stuff. That is the exception, if you will, to the general rule for small conductor protection. So that's why you can have a 10 gauge wire on a 50, 60 amp breaker and you're freaking out because you're saying, wait a minute, I got small conductor rules. No, because it makes reference in 240.4D that you also have the allowances in or G. And in G, it gives you all these other articles where these rules for small conductors. Okay. Now, could you still protect it at that size? Absolutely. Is there a chance that the breaker won't hold or whatever? Probably not. But, still, you could if you wanted. All right, so small conductor rules, and if we go look at it, it says a 10 gauge copper is good for 30 amperes, and that is your protection. So for everybody that said 30, 334.80 wouldn't help you any, Eric. We're just looking for, the question only asks us for overcurrent protection. Danny locked it up. All right, so let's go over here. Click that. 240.4 D7. There it is down there. There you go. Good job. Y'all are getting them. We're getting them. We're smoking now. All right. All right, you ready? Here's the first one that gets this one. And the first one that gets it will be added to my list. Jeff, you're on this thing like twice. We got Tim and we got Danny. All right, so for the purpose of sizing branch circuits, applying fixed, and what y'all are playing for, I'm actually giving y'all more time. What y'all are playing for is a signed copy of this latest book, Grounding and Bonding. Okay? Just came out. All right. For the purpose of the SID branch circuits, and I'm going to look, you got to give me code reference and answer. Again, A, B, C, or D. For the purpose of the sizing branch circuits, applying fixed storage type water heaters, having a capacity of 120 gallons or less, the load shall be calculated at blank. All right. Don't guess. To get it right, I need A, B, C, or D, and I need the code reference. Okay? And I'm not gonna help you with this one. And while y'all are doing that, Danny said, I gave you the code reference already, Paul. Oh, yeah, you did. No, you didn't, Danny. You said it was 6. That's aluminum. That's copper-clad aluminum and aluminum. Incidentally, copper-clad aluminum is just aluminum. It's just got some copper around it. Metallurgically bonded, we call it. As far as ampacities go, they got a little bit of a jump in the 2020. They were happy about that, but guess what? 2023, we're gonna pull it all back. It's got to be your connection. I can't. That's blurry. I can't imagine it was. Not sure that the screen blurry or me. It's got to be the connection because I can't control. My side is clear. Might be that needs to be a little bigger. I can do that. Hold on. Do that here. It might be a little bigger. I can't do it any more than that, guys. It's the best I can get it for you. Oops, then I lose some size here. There we go. It's the best I can get it. All right. What do we got? Word to yo Bama. Welcome, word to yo Bama. Okay, where are we at? Oh, sorry for my... I read it after I saw it. Sorry about that. Sorry. Man. All right. So the purpose of this thing here, 120 gallons or less, the load shall be considered a... Okay, so here's the interesting thing. For branch circuits, you treat it as a continuous load. But interesting enough, you'll see that tomorrow night when we do our one family dwelling breakdown, you'll notice that you don't take it again as a continuous load when you're doing the actual service calculations. You know what I'm saying? I know I am. Don't have no accident. So again, in this case, storage type water heater. So if I had to do this one and I was going to look in the code, I might go back to, again, we don't know. There's no rhyme or reason to the index. I might go back and look under water heaters, and it says water heaters 422.11 F2.13. So if I'm on an exam, I'm going to write both those down. I don't know which one it might be. I'm going to write it down. Everybody seems to think it's 422.13, so we're going to go with that. But, I'm going to write down, okay? All right. So, again, if your stream is blurry, I don't control that. It might be your connection because it's, again, my stream is not only as good as your connection. So, you might have to log off, back on, or whatnot, or see what your speed is. Go to speednet.net. All right, so again, let's see. So in that case, it says 422.11, 422.13. Those are ones that I'm going to write down. So I wrote those down, and I went to 422.11 first because that, obviously in order. I just write them down. And remember, at this point, you're doing what's called bold searching. It means you're looking for the searching of the headings in order to get you where you need to be. So I'm looking at 422.11. I don't know what I just said, but I'm looking at it here. And I'm looking down, and I'm like, okay, I got an A and a B, and I got a C and a D, okay? And I got an F, right? Okay. So then I got all the way down. Then my next one was 422.13. 11 didn't do me no good. Boom, I see storage type. Trigger. I'm bolding. Trying to read y'all's post while I do it. Bolding. And then I notice that it says that it is a continuous load for the purpose of sizing the branch circuit. Just remember, not when you're doing it and treating it as an appliance. When you're doing your full feeder or service calculation, you just take whatever the question will give you, whatever it is in watts or whatever, you take that. You don't start doing continuous load for that. It's already done in the branch circuit. Just remember that. So I think we had enough time. Everybody's got B. I think everybody's good. B is a continuous load. There you go. Good job. I delay and get everybody enough time. All right, next. Y'all are doing good tonight. Next. What is the maximum length of a flexible cord that may be used for connecting a recirculating water pump motor installed in a swimming pool at a multifamily dwelling? Wow. So it's a multifamily dwelling. It's a recirculating water pump motor. And we're looking for flexible cord length, maximum length of flexible cord. So it's something new here to tell you guys. So tell me, somebody post, what article should we be going to? Danny's just throwing up numbers, man. Not even giving code references. Danny's like, I don't need no reference. I don't need no reference. I'm just throwing them up there. He says, I don't need to reference nothing. My name is Danny. Sorry, Danny. Never met Danny, but I feel like we would hit it off. And I like teasing him. We'll meet one day, Danny. You'll come to one of my seminars somewhere. All right, so let's see here. So for me, if I was just acting like I've never done it before, and I serve on this code panel, so by the way, so any rate, so if I act like I didn't know, I would go to swimming pools, fountains, similar installations back in the index, because I'm forced to go to the index if I didn't know. Absolutely, 680. Very good. Y'all are in 680. Now, when I went to the back of the book and I'm looking at swimming pools, fountains, and similar equipment. That tells me it's 680. And now the question's asking me about flexible cord and its recirculating water pump, right? So I'm sitting there going, okay, cord and plug connected equipment, and I've got quite a few. I mean, I've got 0.8, 0.21A3. You know, that one's for that one. I got 0.22B5. I got 680.31. I got 0.42, and I got 56. Now, my history tells me that it's not going to be up in the 40s because that's for spas and hot tubs. Okay? So, again, if you get used to things, luminaires, you know, around the dot 22. Dot 21 sounds more motor-driven when you're in dot 21, so that might be your, something type of thing. So, for me, I would probably, if I was writing it down, I'd probably, except for the A's and 3's and all, because I'd be scoping by the time I got there, I would be writing down, if I was on an exam really quickly, I'd be doing cord and plug, okay, 0.21, 0.22, as far as I'd go for that. And you go down to motors, you see 0.21C, and then I'm just looking to see if there's anything else on here that might be. Okay, it's multifamily, so go down and see if there's anything else that I would have that would be something worthy of me writing down, okay? And I'm just looking, and I'm seeing anything, and I was like, no. So anyway, so if that's the case, I'm going to go to 680.21. That was kind of somewhere where I was going to be. I'm just acting, we'll just work this like I have no idea what the distance is. I don't know. Okay. All right. So let's see. What answers do we have? Danny. Okay. So if you go to look it up and you're looking in, permanently installed pools, kind of poorly worded question, but we'll just assume it. Like, it didn't say it was storable. It didn't say, so we're going to assume it's fixed. And I imagine it would be if it's multifamily. It says motors. We're dealing with a motor? Yep, motor. It says pool associated motors shall be permitted to employ cord and plug connected. The flexible cord shall not exceed 3 feet in length. The flexible cord shall include copper, blah, 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 all that good stuff. And there you go. So Danny says it is D. Got kicked off. I didn't do it, Lewis. Promise you. Oops. Sorry about that. I opened up my voltage drop thing again. All right. For those that missed it, we did a voltage drop presentation from when we started. And there it is. Interesting. If you're in the 2014 code, it was 680.21A5. And if you're in the 2017 code, it's 680.21A3. So you kind of see how we work that out. It's a motor. We know it's swimming pools, so we know we're 680. And that type of thing. So, y'all that had to reconnect, you still can see me, right? So I didn't go away, so it had to be connection issues. It might be YouTube's end, who knows? They have issues, but y'all can still see me, and you came back, it's still where we're at. So, right? You can see me? Hopefully you can see me. Let me go check the stream real quick. Yeah, I'm still on there. Okay. All right. Stream is still there. Okay. Anyway, so here we go. That was fairly easy. You saw how we had dissected that one. If you didn't know it, see, the beautiful thing about an exam is if you put your time in and you study like this, you study with a reason, you study with a purpose, you look up every question, you don't care about the time when you're studying. What happens is when it comes down to that pressure moment in the last week or two where you do start timing yourself, then what will happen is you get on the exam and some of these things that you've been taking the time to look up and look around in the code will start to click. And it's just, it's not something new. It's just the way it works. All right, so let's go back to the question. Another question? All right, you ready? This is another one. Should get you some time here. When nails are used to fasten metal boxes to wooden studs, the nails passing through the interior of the box. I'm sure y'all probably seen some of those metal boxes that have the holes where the nails actually pass through the middle of the box. Okay. It says the nails shall be within blank inches of the back of the box. What do you think? What's your questions? Well, let's identify it. Well, obviously we're talking boxes, right? Lewis says B. Oh, wait a minute, Lewis said. Oh, God, you're right, Lewis. I had to find out who got it right. The first, who got it completely right. In other words, the code number, D, and the answer, 3 foot. Let's see, I got to go back and look now. See who did it right. I got some 680s. I got some 3s. Looks like Danny. Danny, you're already on here, so I get to put you twice. Got to get both. Okay. Now this one doesn't get you on the list, Lewis. That was the last one. I'll do another one in a minute. Because Danny and Jeff have just increased their odds. So Tim's not in here tonight, so he increased his odds. But I'll have some more. All right, so 334 is not going to be good enough. We need the code reference all the way down to the code reference, not the article. We need the section, code section. All right. But good identification is that when you looked at this question on the exam, the first thing that came to your mind was it's a box. First thing that came into mind. All right. It's a metal box. Okay. Things like that. You're most welcome, Lewis. I'm glad you get something out of the videos. Again, people ask me, what do I get by coming on and doing this? I literally, my wife is in the other out of my studio. She's out there, and I do this, and I take a lot of time away from her from the stuff that I do. So we all thank her because she lets me do this, and I enjoy helping you. So if I can help you. I'm not the best in the world. There's many people that are better than me, but I like to do what I can do to help. Okay? All right, so we know it's 334. So if I was looking in the back of the box, if I was looking in the back, I'd probably look under boxes and all that type of thing. But I know it's in 334. But is this somewhere going to get me closer in the back if I literally didn't know? Are you going to simply go and just kind of move your way through 314? You know, just boom, 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 boom through 314? Or is there anything in the index? And again, like we say, the index isn't the holy grail. Not everything you can get there from the back of the book. So that's why we do this stuff, so that these questions stick in your head when you're taking the exam. Somebody asked me that the other day. They were like, Paul, you're looking up questions. Exactly right, because these questions or some derivative of these questions could be on an exam. And so by us doing it this way, it's going to lock it in your brain, okay? We're not about timing right now. Maybe I'll do one of my evenings, I'll do what's called lightning round, and then I'll put a timer on the screen, and we'll do it that way. But right now, we're just trying to learn. We're just trying to learn the code. So boxes. I'm just looking real quick. I know you guys have something on the screen, but I'm just looking. Boxes. And I want to see if I have anything that remotely would help me under boxes. Just looking. Y'all can look too. Just want to see. Well, I got a bunch of securing stuff. Okay. Under securing and supporting, which is kind of what we're asking, if I was on an exam and I came across this, I would write, okay, there's a 300.11. I know that's a general use. It's not really into boxes. We already identified it's 314. Me and you, we identified that. So I probably look and see there's a 314.23. And then, of course, there's a 392, which we know that's his cable trays. So that's not even anything to do. If you did your homework and you did those flashcards I used to talk about making, we have flashcards that are built into the Fast Tracks program, but you can make your own with index cards. You should be doing that anyway if you're preparing for an exam. You should write a code article on the front and put on the back what it is, and just get used to those articles. And so in this case, I would probably say 314.23 is something that's important to look at, and so I would write that down. Now, nothing else in there helps me too much, except for there is a wall or ceiling box, and that is 314.27. So I'm probably also still going to write .27. Remember, we're in exams, so I'm going to write those down so that I don't have to come back. So I'm going to write .23, and I'm going to write .27. Just going to do that. So I'm going to go over to 314. Oh, and I know I should ask this real quick while I'm doing this. Mario, I can't remember what it was, but did Vince get you my response to, I can't remember what it was during your recording, paralleling of equipment grounds or whatever. Did he get you my response? Anyway, all right, so 314. I told him to give it to you. I can't remember what it was again now, but anyway, so 314.20. I think I said I didn't really write it down. I'm just faking. .23, and I'm looking at nails, and that question asked me about nails, right? So I'm just going to look and says, nails and screws were used as a fastening means, shall secure boxes using brackets outside, blah, 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 blah. Now it says, or by using mounting holes in the back or in the single side of the enclosure, or they shall pass through the interior within 1/4 of an inch of the back ends of the enclosure. So this is 314.23B1. Okay, Mohammed. Got it right. Lewis, got it right. Y'all all got it right. Mohammed, the first one you had was 17B. Yeah, no, that's just sheathing going in it. I think you realized that and you got the answer down. Okay, cool. Cool. So let's go here. So right there. Y'all are getting savvy. Y'all are getting savvy now. Okay, next one. What is the maximum? Oh, am I on it? Make sure I'm on the screen, folks. There we go. What is the maximum distance in a 125 volt, 15 or 28 receptacle outlet may be installed from a hot tub installed indoors at a dwelling? What is the maximum distance? Oh, away from the hot tub. I was sitting there going, man, you're going to ask me a voltage distance question? Don't think switch, Danny. Danny was quick to throw that 5 foot. I mean, he was like, boom, 5 foot. You know, he's thinking switches, man. We're talking receptacles, Danny. Hold back, pull back, Danny. Hold on. I don't have any music for you, Danny. I've got my theme song for you, Danny. Listen.
Shut up and sit down.
Okay. Lewis, 680.22, he says, oh, IM says 20 feet. Danny says 5 feet still. Danny, we're on Danny. But Lewis gave a code reference and didn't give an answer. IM gave a distance, but no code reference. I'm helping you study, folks. Although you're driving, so you don't get to look up. I don't want to read about it in the news. Lewis said 6 feet. All right, now we got all kinds of numbers out here now. Now we're gonna have to look this one up. Okay, so it's 680 because it's dealing with a hot tub, right? So we know it's at least in 680. So we're gonna go over to 680. Okay. Now, couple things to think about here, and I'm gonna look up here real quick for you before I put it on the screen. And we know hot tubs are in part 4, right? 4. And incidentally, shameless plug, up on my YouTube channel now, I put all of our videos in these playlists. So even my old videos that are available, and God, don't laugh at my old videos. We have progressed a little bit since then. But videos that are in there, I have a series on swimming pools, and I got to update it but it's got, I don't know how many Danny knows. He watched it a bunch. There's like seven parts to it. So go watch it. Okay. Receptacles. So it's an indoor installation. Didn't it say indoors? Yes. So that's key, right? So we know we're in hot tubs, or we know we're in 680, no brainer. We know it's indoors, and that's a big deal. Think about this, guys. When you have hot tubs, it's either outdoors or indoors, and the rules change a little bit whether it's indoors or outdoors. So if they tell you that it's indoors, they got to be telling you it's for a reason, right? So we have rules for receptacles outside, and we have receptacle rules for them inside when it comes to distance between hot tubs, okay? All right, so, anywho. So, let's look at, real quick here. Hold on a second, I want to make sure. Yes, okay. So we know it's indoors, it's dwelling, it's a hot tub. We know it's 15 or 20 amp receptacles, 125 volt. Incidentally, the 125 is a receptacles NEMA rating. A little tip for exams. If you see a question that says, gives you the nominal voltage, you heard me and Mario talking about it, was if it is a 120 or 240 or something like that, then it's talking about the branch circuit. So it can narrow your search down when you're preparing for exam. If you see something that references 125 or 250, then you know that that's a NEMA rating. That's a device. So the question's dealing with the device, and it might save you jumping around. A good example of that with the arc fault circuit interrupter. That's every bit about a branch circuit, even though they do make AFCI receptacles. If you see the question about AFCI is talking about 120 volts, and you know it's talking about the branch circuit. Okay, just a little tip. When you're looking through the code and you see references to actual NEMA ratings, then you know you're something to do with the device or something about a device. So it might help where you're at in the different code sections. Just things to think about. So in this case, it looks like we're in 680.43. It's an indoor spa. Okay. And the first one you get to is receptacles. It says at least one 125 volt, 15 to 28 receptacle on a general purpose branch circuit shall be located not less than 6 feet from and not exceeding 10 feet from the inside wall of the spa or hot tub. It goes on to say the location. It says, and that's A1, it says receptacles shall be located at least 6 feet measured horizontally from the inside wall of the spa or hot tub. All right. So this one says, interesting, this says 6 feet. And this one says 5 feet, 10 feet, 20 feet, and 15 feet. What do we got going on here? Well, this ought to be interesting. What do you think? Let me see what everybody says here. I've got A. Okay. And let's see what I got. 6A.22A. Jeff's got 6A.22A for 20 feet. The max is 20 feet. So it's asking us what? Maximum? All right, you're losing me, Jeff. I'm getting you on a bunch of responses now. So I'm not so sure which one you're on. So it's asking what the maximum distance is for the outlet. So at least one, not to see 10 feet, and then 6 feet. So I don't know. I see some bunch of answers here. And Christian's coming in with the 10 foot. I think y'all see something now. We got Mr. Prolific coming in here on it. So let's go back and let's go and answer this question. 680.43A. So maximum was the trigger here. Okay. It didn't really ask about the location. It's actually talking about the distance. Okay. So you have A and then you have one, so So it's got to be at least 6 feet, but not to exceed 10 feet. But it's got to be at least 6 feet away. But the maximum distance it can be is 10 feet away. Okay? And that again is that's a general purpose receptacle. So how did we do here? Jeff 680.22A4. Only problem with that one is just use this for some training here. 680.22A, that's receptacles, Jeff, but the problem with that is in part 2, right? And we're in part 4, and what part 4 says up in the scope of it, Jeff, it says electrical installations for spas and hot tubs shall comply with the provisions of part 1 and part 4. So I don't have any ability to go back to part 2. So we wouldn't be in 20.22 because I don't have any ability to get back to part 2, because under the actual general provisions of part 4, it says that for hot tubs and spas, I can only use part 1 and part 4. So I can't get back to the receptacles we have in .22. I can't, that's for swimming pools. So that's the unique thing about part 5 is spas and hot tubs. It uses all the general requirements in part 1, but then it uses all the information in part 4 on its own. So Mr. Prolific, absolutely right. So you've got indoor, hot tub, and again, all of those things are definitely triggers. I got there again by going back to swimming pools, okay, and then going down from there, but that type of stuff, okay. So just remember that was kind of one that you might see on an exam. They love to do those distance things. Oh my God, they do. In fact, I've been in the meetings where the people the administrators are like, let's have some more distance questions. Write some more, and we have to write more. And it's like, come on, I get old. All right, all right, y'all are doing great. All right, here we go. You ready? It says all 125 volt. Ooh, we're talking receptacle now. Single phase, 15 or 20 ampere duplex receptacles installed in a residential garage must be provided with blank. A weatherproof cover. Really? Inside of a garage? Probably not that one, folks. The next one is a metal faceplate. Really? So this is one of those ones where you just bought you some time, baby, on the exam. You're like, pow. You see, hey guys, if you get 100 questions of this on your exam, this is what it's going to sound like to you. Hold on. This is what it's going to sound like if you get 100 of these questions like this on exam. Ready? Sweet smell of an easy license. All right. Unfortunately, it's guys like me that write these exams are not going to make it that easy for you. Sorry. All right. So yes, we don't really have to even look this one up unless somebody wants to give me the code reference. There you go, Louise. Lewis. I said Louise. I'm sorry, Louise. Lewis. Sorry, Luz. Luz? I'm going to check you now. 210.8A, definitely residential. So let's see what we got. I'm going to double check you. I feel you. Let's see here. 210.8A, 210.8. Y'all all look it up again. For 210.8A. Garages. There you go. Very good. Who's got the 2018 code book? There ain't no such thing as a 2018 code book. You either got the 2017 code book or you got a 2020 code book. You got no 218. If you do, I'll give you $1,000 for it. I'll give you cash money. All right. Very good. So let's answer this question. Let's move on. Y'all are doing great tonight. This is one of your best sessions. All right. Next. All right. You ready? All right, folks. When sizing, and I'm doing this for you, AM, because I know you're driving. Okay. And it is When sizing the overcurrent protection required for a non-motor operated appliance, such as a electric range, water heater, and cooktops, the overcurrent protection shall not exceed blank percent of the rated current of the appliance. Where this value does not correspond to the standard overcurrent device ampere rating, the next higher standard rating shall be permitted. 115A, 150B, 175C, or 125D? What do you think? A little different question. Kind of a little different question. Asking about overcurrent protection, but it seems like it's asking it, and it's talking about the current rating of appliances. So, if I was, actually, tomorrow is our normal 8 p.m. class. It's my normal Electrician Live episode, my normal one that I do. That's the one that's syndicated everywhere. We have over 300,000 active listeners a month to that series. Not at the same time, but that would be amazing. But it's not. And that is the one we do on Saturday evenings here. Same place, same place, same bat channel. And it's really supposed to be a podcast, and wasn't supposed to be the video. The video was just supposed to run like kind of for lack of a better term, it was like a Howard Sternish thing where the camera's just on. You know what I'm saying? It's just on. But I decided that I would try to do a radio show, but also talk to the camera, talk in a way that I can convey it, right? Mr. Prolific, that doesn't answer the question. We do know 125% of continuous load and 100% of non-continuous, but that doesn't answer this question. I'm gonna do a hold on. All right. So I'm looking at appliances just to look, and for load calculation, installation, markings, disconnects, markings, overcurrent protection. We have 422.11, all those kind of goodies I'm looking. I'm just looking. All right. I know what my answer would be. See you, Tom. So see you tomorrow. Okay, you leaving out? Have a good night. Thanks for hanging in with us. We're coming up on the 2-hour mark, so I'm not going to be a lot longer. My wife would kill me, and she won't let me do it 2 nights in a row. But I'm going to go look at 422 just to look, even though only one of those things probably fell under 422, incidentally. But I'm going to look because I know the answer, but I want to see how I get there. I want to see if there's something that it gets me there. And I think there is. Okay. The branch circuit supplied by a single non-insulated appliance. The rating of the overcurrent shall comply with the following: not exceed the marking of the appliance, not exceed 20 blah 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 blah, not exceed 150% of the appliance current if the overcurrent device rating is not marked and the appliance is rated over blah blah blah. Okay. All right. Individual circuits. It also reminds us, it says the branch circuit rating for an appliance that has continuous load other than motor operated appliances shall not be less than 125% of the marked rating and not less than 100%, blah, blah, blah. So, interesting thing about this is, I'll kind of touch on this with Mr. Prolific because he brings a good point up here. We don't generally take electric ranges at 125%. We don't take them as a continuous load in our calculation because they're not. they're not a continuous load, right? So just kind of just thinking out there, I'm like, it's not a continuous load. And I don't know